Hi, it's JJ here again. Today I want to talk to you again about some future engineering topics, specifically a project I was working on that involved Onshape and Leo that you can see is open over here. I want to show you the model here you can see it's being animated and how it would move. You see the bearings here, just a cut section. You can see it moving through, rotating. And here's the motor. And here is the key thingamajig whose name I specifically always forget. Even 20 years of experience doesn't mean you remember everything. So I want to look for this part. This is going to be the first thing we look at. I'm going to try to use Leo here to run the search. I've got my prompt ready. I'm going to ask him to help me find the part that connects the drive shaft to the drive mechanism. I'm describing it, and I'll attach a screenshot. So I've attached a screenshot, and now we'll see. We'll ask Leo to help find this part. Leo has found the parts, it's found the rectangular parallel keys, and we have different parts that I could either look at what Leo has found on the internet, and here's all the information summarized nicely, or I can see what he found in my local library. We can open it in my folder, and it turns out that this is the part, one of the parts I was looking for. Now I want to show you how I like to import this into Onshape. I just copy it, the path, close that. We go to Onshape, import, opens it. And just like that, we found the part in our local library and it's imported into Onshape, ready to be placed in our assembly. So I've already placed it in our assembly and it's over here. The next step that I wanted to do is to conduct a static simulation, assume that there's a force, torque of 500 newtons being applied here on the shaft to see if this will be able to handle the stresses. So here's the analysis that I conducted in Onshape. There's a great static simulation tool. We applied a load of 500 Newton meters, and these are the results. And we can see the results over here, where we get the range of numbers that you can see here on my screen. So now what I want to do is ask Leo to conduct the same calculation for the von Mises stress. I've pasted here the prompt. I tell Leo that I'll be using a rounded machine key, 316 stainless, the dimensions, and I'm asking him to calculate the von Mises stresses acting on it. Static load of 500 Newton meters is applied. And I also give it the shaft diameter, which is 20 millimeters. Let's launch that and see what we get. So here you can see how Leo shows you how he's going to conduct the calculation. Always double check the sources. Never trust an AI blindly. Some of the information was sourced here from ANSYS's website, and we'll see what the final answer is. So Leo found that the von Mises stress is acting here on this key. Notice the dimensions of the key, that it will be 433 megapascals. And it summarizes here, and you have the Python code in case you want to write a script and have that in your library as well. It's always good to see that the numbers match up between the calculation and the static analysis here we conducted in Onshape. Now that I'm considering the high torque we're dealing with, I'm not confident in the bearings, and I don't have a lot of experience dealing with bearings. So I'm going to ask Leo to suggest which types of bearings might be best suited for a high torque shaft. If there's other people on my teams who've dealt with bearings and have downloaded information, I might not know that, but Leo will be able to find that. And I can see that's what happened. This is what these colored links here refer to references that are found on our local catalog versus these links you can see are references that are found on the internet. So I can press on the link and what can I see? That in my local library, someone on my team has downloaded the NSK rolling bearings catalog, a comprehensive catalog that has a lot of information. I can see why. And I'll be able to find all the information there. Most importantly, I also see that someone else on my team has been dealing with this, so that might be a good conversation starter to seek help within my organization. I really just wanted to show you how Leo could help you find stuff within your local directories and on the internet. And this way you can easily compare the different information and conduct the calculations to help you confirm, in this case, results from from a simulation. So thank you again for watching. If you have any questions or suggestions, please write in the comments and keep following. Thank you and have a great day.